Hello class, welcome to day 11. This will be lesson 1.11. In this lesson you need to be able to calculate angles and be able to give a justification for your calculation of angles. So I want to take a look at that to start with, and then we will talk a little bit about the translation of lines. So to get started, I have an applet here done up where I have a pair of parallel lines. And I know these lines are parallel because line CD was translated along vector AE to get line C prime D prime. So I know these lines are parallel. So the line AB here is the transversal. Okay? So if we knew, for example, that I had an angle that was 50 degrees, this angle here, how could I find the measures of the other angles? Well, one of the things that you hopefully you watched the videos. There were some notes on it. I did put in some videos on different angle relationships. One of those angle relationships was what was known as corresponding angles. So when I look at this particular diagram, I know that angle AED corresponds to angle E, and I need a midpoint. Let's get an intersection point there. Angle EFD. Okay, and I know that they are corresponding angles. Well, one of the things that we know about with corresponding angles is if the lines are parallel, these angles have to be congruent. And that proof can be done by showing, I'm going to highlight this with a polygon so that you can see it. So if I'm referencing this angle here and I want to find the measure of this angle here, I could do a translation of this angle and it should map right onto this angle if the lines are parallel. So if I do a translation of this particular polygon by that vector, you'll notice that boom, it lines up perfect. They are exactly 50 degrees each. Now I can prove that that only works for parallel lines, because if we were to have another line down here and I intentionally made it to where it looked like it wasn't parallel, but sometimes you are given diagrams where they may look like they're parallel when in fact that they're truly not. So at any rate, I can prove that this theorem is true because if I translate this by this vector here, oops, and I forgot to put a point there. So let me go put a point. There we go. Point I. Okay, so if I translate this particular polygon by this vector, you notice, look, it doesn't match up. It's close, but it doesn't match up. And when those particular lines are not parallel, you can tell that that angle will not be congruent. Okay, so I know that up here on my parallel lines where we started, that angle AED is congruent to angle A prime E prime D prime because they're corresponding angles and lines are parallel. Okay, so I could also prove some other angle relationships. For example, if this angle here is 50 degrees, I know that angle AED and angle AEC make a linear pair. So this angle over here has to be 130 degrees. So let's mark that 130 degrees. Well, if that angle is 130 degrees, then we know that this angle down here has to be 130 degrees because we proved these lines are parallel. And these two angles are corresponding. This angle corresponds with that angle. Well, if that's the case, and we've proved that this angle is 50 and this angle is 130 by the corresponding angles, well then we could easily say this angle here is 50 because these angles are vertical, and we could say that this angle here is 130 because these angles are vertical. So that is one method that you could use to prove angles. Okay, so let's say that we know this angle here is 130. What is the measure of this angle here? Well, we proved it with corresponding angles. This is 50. What I want you to notice is that when these lines are parallel, when CD is parallel to C prime D prime, these interior angles on the same side, they will have a sum of 180. Oops. Okay, and that goes true for both sides. So this other side over here, they're going to have a sum of 180. So that gives you a couple of different ways to calculate angles. One of the other things that I wanted you to notice when we were doing this is that we know that if this angle is 50, by vertical angles, this is 50. And this one is 130. Well, these add up to 180. Well, you also have a linear pair here. So this angle, this angle that's 50 is also 50 down here. These two are what's known as alternate interior angles. And so if this one's 50, then this one has to be 50. Okay, enough on angle measures and how to find angle measures. Let's talk about translating lines now. Okay, so here we have two lines that intersect. And if I was to translate line CD along vector EF, what would happen to the lines? What would their relationship be? Well, let's find out. So if I do a translation of line segment CD along vector EF, that translates that line down here. What do I know about these lines? What has transpired here? If you notice, this vector EF, C and C prime should be the same distance as EF, and D and D prime should be the same distance as EF. Well, in order to prove that, here once again, we could use angles. So we could prove that those lines are parallel by simply taking this polygon now and translating it along this same vector. And look at what happens. Those angles are congruent. So that means that these lines are parallel. And that was one of the big concepts that we needed to make sure that we understood when we're translating. When we're translating, you're going to end up creating parallel lines. If you notice AD and A prime D prime, those lines are parallel. We know that ED and E prime D prime are parallel because we just proved it. And then obviously AE is along the same line as A prime E prime. And this is an example of what happens with a translation. Okay, the other thing that we can also do is we could also rotate a line or a line segment. So I could select my particular line segment and I could rotate it around point E 180 degrees. And look at what happens. It's back on itself. But if I take and I rotate it, oops, undo. If I take and I rotate the line around point F 180 degrees. Now what has happened? It looks like a translation, but actually it wasn't, because look, here's D and here's D prime. Here's C and here's C prime. Well, would these angles still be congruent? And the answer would be yes, because remember that these are vertical angles up here. And so when this was rotated, you think about it being flipped around, what happened? The vertical angle, instead of the angle being here, it's over here, but these are vertical angles. And vertical angles are congruent. So either translating or rotating, we can still end up getting congruent angles. And so that's really important to know. I could have also done a reflection. I could reflect it over that point, and I would get the same results, only I'd have C prime over here and D prime over here, which then it would really look like a translation. So if I was to reflect a line about this point, oops, I selected the wrong one. Let me try that again. Reflect about a point, here it is. So if I reflect this line about this point, it reflects down. It's like a rotation. So you got D, D prime, C, C prime, because you're reflecting over the point. So D is reflecting over that point F, and C is reflecting over that point F. Now, if we had a line segment in there, let me go back. If we had a line segment in there, and I reflected over that line segment, then C and C prime would be directly above one another. So I could reflect this about this line. And boom, it moves it down to where these are parallel. All right, so if you have any questions about those, feel free to give a shout out to me in Teams. Just another note, please make sure that when you get to the notes page that you pay close attention to the notes that are on that page and the videos that I got posted there that talk about these two different theorems. Okay, so once we prove the theorems, then we're allowed to use the theorems. And that'll wrap this lesson up. Have a great day.